Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on CO2 sequestration model. And in today's video, we will run the previous case that we created using Builder. In the past video, we add water injection well using Builder, and now we will run and we will see what happened. Will the water injection improve the CO2 trapping, or will it jeopardize the CO2 trapping? Okay, we will first perform the case with 25 meter cube per day of water injection. So as usual, it's very easy. Just drag and drop it on the gem and click on OK. Let the gem calculate it and give us the result. Okay, still running. All right. Okay, almost completed. Okay, let's wait. Okay, as usual, the running will produce .log, .out. You can read the result in text when you open the .out. Okay, the running is complete. So now we can just visualize the SR3 using results. Okay, so this is our case. And let's go to the model. Okay, this is the model in 3D view. And let's check the IK2D view. First, let's check the pressure. Okay, just like before, the pressure is around 12,600 kPa. Okay, and let's check the gas saturation, of course. Or maybe we can just go directly to compare it with the case without water injection. So here, okay, and put the case 2C on dashboard and put case 2B on the same dashboard. So we have like this. Okay. All right. Now let's go to gas saturation. Okay. And play. So you see difference, right? Okay. Yeah. You can see the difference. Interesting. Here, the CO2 plume at the top spreads farther, okay, propagates farther, and you can see the profile of the residual trap, residual CO2 trap due to residual trapping or hysteresis trapping down there. You also can see here, but somehow this one is a little bit fatter than this one. This one is slim, this one is quite fat. And the CO2 extends not as far as the case without water injection. Okay, we can also go back and check the gas mass density. Let's compare. Will there be difference? Yeah. This one, the density is 545. This one is a little bit heavier, dense, more dense. Oh, maybe this one is 531. Oh, on the left, I think it's, more dense. Let's check the same cell. Okay, let's say for this one, cell 718, 550. This one, 548. So the left case has greater mass density. Okay, and we also want to check, as usual, SG below critical gas saturation. You can see the difference. Right? They're different. Okay. And we can also check the time series as usual. All right. So from here, you can see water injection influence the CO2 trapping, but we're still not very sure will it be for better or for worse. So let's check the time series plot. Special history. First, let's check case 2B, special history, and CO2 track. Okay, so this is without water injection. So now let's add the case with injection. You see, very interesting. So as you can see, more CO2 will be trapped due to water injection. Okay, in this case, we place the perforation for water injection at shallower location. Okay, water can be injected at a shallower location than the CO2 injection. This way, water will move downward, where CO2 will move upward due to gravity. As a result of this movement, there will be saturation changes. And because of this, more CO2 can be trapped in the aquifer. So this gives us an idea that we can perform water injection along with the CO2 injection to improve the CO2 trapping. And of course, after we later on add solubility trapping, there will be further changes. Maybe it will give even better effect on the CO2 trapping. Okay, so now we will go back and we will change the water injection from 25 to 50, and we will see what happens after we run on the gem and visualize it using results. Okay, so we are back and very easy. I will just copy and make the second case juicy. Let's call it 50 like this. Open and change the title a little bit, 50. Now on the script, we will change and we will find the value of 25. If you are not certain what to do, just control find and let's check 25. Okay, so we have 25 here, but it's an eccentric factor. It's not what we want to look for. Okay, the second find is here, 25. And you see it's operate max surface treated water, if I'm not mistaken, STW 25, and continues. So we can just easily change it to 50. So without changing it in the builder, we can just directly change it on the script. Control save, done. Okay, just to make sure, is there another 25? Not this one. Okay, good. So we already changed the water injection rate from 25 to 50. Okay, so as usual, let's run the case. Here we have the dot with injection rate of 50. Run on the gem, click OK, wait for a while, and later we will add the result on the results feature. Very easy, very simple, but we can learn more. We can learn many things from this kind of exercise. Almost there. Okay, complete. Yeah, completed. Just expand this. Yeah, the case with 50 already okay. So let's go to the results. Okay, so this is the same result that we opened already. Data source, add files. Now go to here. Let's add this one, 50 SR3. Click on open. Okay, and then I want to expand. Okay, this one we just add to the dashboard. Okay. Okay, so now we have 3 windows. All right. Okay, and just want to squeeze it. Okay. Wait a minute. Okay. So they are synchronized already. So just to make sure this is the case without water injection. Okay. Oh, this one is with 50. This one is with 25. This one is without injection. So let's go to display. Let's check the gas saturation. Okay, let's go from the start. Play. Okay, you can see the difference, right? So the CO2 propagates even even closer here, not too far. So the more water injection you add, the CO2 somehow will be slower. Okay, the CO2 movement somehow will be more limited because of the water injection. On the right case, there is no water injection, so the CO2 can extend quite far. Okay, with the free CO2 at the top, okay, they rise up due to buoyancy, due to gravity, and some CO2 are trapped because of hysteresis trapping. With water injection, CO2 movement are more limited. Okay, there will be saturation changes between the water and CO2. Okay, and yeah, their movement is limited because of the water injection. And their movement even more and more limited as we increase the water injection from 25 to 50 meter cube per day. And that's what we happen here. And of course, gas saturation below the critical gas saturation. Yeah, you can see the difference between the three. Okay. Very good. Don't forget, this is the injection. This is the condition after only 1 year of injection, both for CO2 and water injection. It's not realistic, because in real life, when we perform CO2 geological sequestration, we maybe will inject the CO2 for 15 years or maybe 20 years, and after that we shut in the well and just do monitoring. Okay, so now lastly, let's check the CO2 trap, and you see, we already have it. So this one, the case without water injection, and if you add water injection, 25 meter cube per day, you will have this one. And the dotted line, you trap even more when you increase the water injection rate. Okay, so again, you can place water injection at shallower location. When you inject the water will move downward, whereas the CO2 will move upward because of gravity. And as a result of the movement, there will be saturation changes and more CO2 can be trapped in the aquifer. Okay, so this is very, very interesting. And this case is completed. In the next video, we will add even more trapping, where we will add solubility trapping. Okay, until then, see you and thank you.